1. Introduction. Welcome to our behind-the-scenes exploration of how American poultry farms produce millions of eggs and vast quantities of chicken meat every single day. This modern farming marvel is the result of decades of technological innovation, rigorous scientific research, and dedicated best practices in animal husbandry. In this voiceover, we will take you into the heart of large-scale American poultry factories and explain every step of the process, from the moment an egg is laid in a high-tech facility to the time packaged meat and neatly stacked egg cartons leave the farm for your local grocery store. By delving deep into the cutting-edge systems, automated machinery, strict biosecurity measures, and advanced feeding techniques, we hope to show just how streamlined and efficient the poultry industry has become in the United States. Unlike the small backyard coops of yesteryear, modern poultry facilities are designed to meet the demands of an ever-growing population. With global consumption of chicken surpassing even beef and pork in many regions, the industry had to adapt rapidly. That is why you'll find these large-scale farms integrating everything from climate-controlled housing to computerized feed dispensers, ensuring maximum productivity and minimal waste. Whether you're a consumer curious about where your chicken and eggs come from, or an aspiring farmer wanting to learn more about large-scale operations, this comprehensive tour of modern poultry farming technology will shed light on every aspect of the process. 2. Historical context and evolution. The poultry industry hasn't always been the high-tech operation it is today. In the early 1900s, chickens were primarily raised in small backyard flocks for personal consumption or local market sales. Egg collection was manual, feed was predominantly kitchen scraps, and disease control was largely a matter of trial and error. However, as the demand for poultry products soared in the mid-20th century, fueled by urbanization, a growing population, and changing dietary habits, farmers realized the need to scale up operations. 3. The scale of modern poultry production. To understand why modern poultry farms can produce millions of eggs and countless pounds of chicken meat, it's crucial to grasp their sheer scale. A single large facility might house hundreds of thousands, even millions of birds at various stages of development. Each bird is often genetically selected for specific traits, such as egg-laying efficiency or rapid weight gain. These giant complexes are part of a vertically integrated supply chain, meaning a single company can control nearly every aspect, from hatchery to feed mill, from grow-out farm to processing plant. With this level of control, poultry companies can optimize consistency, quality, and cost efficiency. By owning or partnering with multiple farms across different regions, they also manage risk. If one farm experiences a localized issue, operations continue smoothly at other locations. This integration allows tight oversight of feed formulation, veterinary care, transportation, and final processing, enabling the consistent production of millions of eggs and tons of chicken meat without significant quality fluctuations. The scale is breathtaking, and it's matched by a level of precision that ensures every bird, every egg, and every process is carefully monitored. 4. Facility design and automation. Step inside a modern American poultry farm, and one of the first things you'll notice is the high degree of automation. Gone are the days when workers manually scattered feed or hand-collected every egg. Today, giant silos store customized feed formulations, which travel through enclosed conveyor tubes into automatic feeders inside vast chicken houses. Each feeding station is programmed to deliver just the right amount of feed at specific intervals, ensuring the birds receive optimal nutrition. Water is similarly automated, distributed through lines that keep it at a consistent temperature and pressure. Equally important are the building designs. Large poultry houses are typically long, well-insulated structures with carefully engineered ventilation systems. Exhaust fans and vents work together to maintain air quality by regulating temperature, humidity, and even the levels of ammonia inside. This is especially crucial when flocks number in the tens of thousands within a single enclosure. Walkways line the side of these houses, allowing workers to inspect the birds without disturbing them. Some facilities even have robotic components that can monitor bird density, adjust lighting schedules, and collect data on feed intake, water consumption, and growth rates in real time. This data is then analyzed to make swift and informed decisions, ensuring maximum yield and minimal loss. 5. The role of hatcheries and breeding. A key component in any poultry farm's success is the hatchery, where the next generation of chickens is carefully incubated. Breeding flocks composed of roosters and hens specifically selected for genetic traits like egg production or meat quality produce fertile eggs that are collected and sent to large hatchery facilities. Here, eggs are placed in incubators that maintain precise temperature and humidity levels to mimic the conditions under a brooding hen. These incubators often contain thousands of eggs at once, and the environment is tightly controlled to ensure a uniform hatch rate. After about 21 days, chicks emerge from their shells and are quickly assessed for health and vigor. The hatchery process from egg to chick is typically automated, reducing human error and stress on the animals. Newly hatched chicks are then vaccinated, often through specialized systems that spray or inject vaccines, to protect them from common poultry diseases. They are counted, sorted by gender if necessary, and placed in temperature-controlled crates. Depending on whether they are destined to become layers or broilers, they're then transported to different facilities that cater to their specific growth trajectories. This streamlined approach to breeding and hatching guarantees a consistent supply of birds, allowing the entire cycle of egg and meat production to run like clockwork. 6. Advanced feeding and nutrition. Feeding is perhaps the most critical factor in ensuring that poultry farms produce millions of eggs and massive amounts of chicken meat efficiently. Modern poultry nutrition is a carefully orchestrated science. Feed is usually a blend of grains, such as corn, wheat, or soybeans, protein sources, vitamins, minerals, and sometimes specialized additives to support gut health. Formulas are developed by nutritionists who tailor diets for each stage of a chicken's life. For instance, broilers require rations with higher protein content to support rapid muscle growth, whereas layer hens need balanced amounts of calcium to maintain strong eggshells. Automation plays a big role here too. Computers in the feed mill track nutrient levels to ensure each batch meets precise standards. Trucks deliver the feed to the poultry houses, where it's automatically dispensed according to the bird's feeding schedule. Some operations employ sensors to measure how much feed is consumed daily, which helps farmers adjust rations if they see any deviation in the flock's weight gain or egg production. Proper nutrition not only keeps the birds healthy and productive, but also reduces waste and cost, thereby maximizing efficiency. 7. Climate control and housing systems. Temperature and humidity can drastically affect a chicken's growth rate and egg-laying capability. Modern American poultry farms utilize advanced HVAC, heating, ventilation, and air conditioning systems that maintain optimal climates for the birds year-round. These systems include tunnel ventilation, large fans installed at one end of the house, pulling air through cooling pads at the opposite end. During warmer months, water runs over these pads, and as air is drawn through, it cools the entire house. In colder climates, heaters and insulation keep the interior at the right temperature. In addition to temperature controls, lighting schedules are manipulated to stimulate egg production or control the growth rate of broilers. Chickens are sensitive to day-length cues, so farmers use artificial lighting to mimic long summer days, encouraging hens to lay eggs consistently. Meanwhile, young broiler chickens might have specific lighting programs that balance rest periods with feeding times to optimize weight gain without causing undue stress or skeletal problems. The goal of these sophisticated housing systems is straightforward. Maintain an environment where the birds can thrive, thereby producing the highest quality eggs and meat possible. 8. Egg collection, handling, and processing. For layer operations, one of the most visually striking aspects is the automated egg collection system. Inside these facilities, hens are often housed in rows of tiered cages or in cage-free aviaries, depending on the farm's production model and consumer demand. In cage systems, each tier is equipped with a sloping floor that gently rolls the eggs onto a conveyor belt, which then carries them to a central collection area. This drastically reduces egg breakage and contamination since fewer hands touch the eggs. In cage-free or barn systems, eggs might be collected from nesting areas, but the principle remains the same. Minimize manual handling through automated belts and trays. Once the eggs arrive at the collection station, they undergo a cleaning process that typically involves washing, drying, and candling. Candling uses a strong light to check for internal defects or cracks that aren't visible externally. In production of broiler chickens for meat, while layers are specialized for egg production, broiler chickens are raised specifically for their meat. The process begins at a hatchery where fertilized eggs from genetically selected breeding stock hatch into chicks bred to grow quickly and efficiently. Within hours of hatching, these chicks are placed in temperature-controlled transport crates and sent to specialized grow-out farms. Here, they live in large open barns with deep bedding material, which is regularly monitored and changed as needed to maintain hygiene and bird comfort. During their lifespan, usually about 6 to 7 weeks, broiler chickens have almost constant access to feed and water, allowing them to reach market weight rapidly. Farmers closely track feed conversion ratios, a measure of how effectively the birds turn feed into body mass. When the chickens reach the desired weight, they are carefully loaded and transported to processing plants where they're humanely slaughtered, processed, and packaged. Advanced processing facilities use automated systems for stunning, plucking, eviscerating, and chilling. The result is fresh or frozen chicken portions that meet strict food safety standards, ready for distribution nationwide. This tightly controlled process ensures consistency in size, taste, and quality for the consumer. 10. Quality control, biosecurity, and sustainability. Maintaining impeccable standards of quality control is paramount in an industry that supplies such a large share of our protein. Biosecurity is the cornerstone of these standards. Poultry farms implement strict protocols to prevent disease outbreaks. This includes controlling access to facilities, requiring workers to wear protective clothing, and disinfecting vehicles that enter or leave the premises. Visitors are often prohibited or heavily restricted, and employees undergo training to recognize early signs of disease in the flock. Should an outbreak occur, swift containment procedures are enacted, sometimes involving partial or complete quarantine, additional vaccinations, or other measures. Farms are also subject to regular inspections by state and federal agencies, ensuring compliance with animal welfare, environmental, and food safety regulations. On the sustainability front, farms are increasingly adopting practices to reduce their environmental footprint. Nutrient management plans address how waste is used or disposed of, often turning chicken manure into fertilizer. Many farms are exploring solar panels and other renewable energy sources to power their facilities, further minimizing costs and emissions. By blending eco-friendly initiatives with rigorous biosecurity and quality assurance, modern poultry farms aim to safeguard public health and the environment while meeting consumer demand. 11. The human element, training and safety. Despite the high level of automation, people remain a critical part of the poultry farming process. It takes a trained, dedicated team to manage everything from hatchery procedures to final product packaging. Farm workers monitor bird health daily, checking for signs of disease or distress. They adjust feed rations based on real-time growth data and calibrate ventilation systems to maintain ideal living conditions. Maintenance teams ensure machinery such as automated feeders, conveyor belts, and climate control units run smoothly with minimal downtime. Safety is a top priority. Poultry facilities can be hazardous if proper precautions aren't taken. Workers handle heavy equipment, manage large flocks, and sometimes work around live electrical systems in wet environments. Comprehensive training programs teach employees how to operate machinery, handle birds humanely, and follow hygiene protocols that prevent disease transmission. Personal protective equipment, PPE, such as gloves, boots, masks, and eyewear, are standard. Ongoing education ensures staff stay updated on new regulations, technologies, and best practices. This emphasis on worker safety and training not only safeguards employees, but also upholds the quality and welfare standards of the farm's operations. 12. Future innovations and conclusion. The American poultry industry continues to evolve, driven by consumer demands, scientific breakthroughs, and the global push for sustainability. Researchers are looking into alternative protein sources, like insect-based feeds, to lessen reliance on soybean and corn. Automation may soon advance into robotic chicken watchers that can individually monitor birds using artificial intelligence, checking for signs of illness, adjusting feed, and even predicting when a particular flock should be moved for processing. Genetic advancements aim to breed even more robust chickens that require fewer antibiotics, grow faster on less feed, and produce eggs at consistently higher rates without compromising the animal's welfare. In conclusion, today's modern poultry farm is a cutting-edge blend of technology, biology, engineering, and conscientious animal husbandry. From the precise temperature controls in hatcheries to the efficient conveyor belts whisking eggs away, these facilities are designed to deliver a steady supply of high-quality protein to millions of consumers. The journey of a single chicken from hatchery to processing plant is meticulously managed at every step, ensuring optimal outcomes for both the birds and the bottom line. As we look to the future, American poultry farms are poised to adopt even more groundbreaking technologies, reinforcing their role as indispensable contributors to our global food supply. Did you know that every single McDonald's hamburger has a story? A story that begins far away from the Golden Arches and goes through an incredible journey before it lands in your hands. Today, we're going to explore the extraordinary process of how McDonald's hamburgers are made, from the humble beginnings of their raw ingredients to the sizzling final product. It's a journey that involves innovation, precision, and a touch of history, all coming together to create one of the most iconic foods of modern times. Let's take a step back in time to understand where it all began. McDonald's wasn't always the global fast food powerhouse we know today. In 1940, two brothers, Richard and Maurice McDonald, opened a small drive-in restaurant in San Bernardino, California. Their vision was simple: serve quality food fast. In those early days, hamburgers weren't the industry-defining item they are now. It wasn't until Ray Kroc joined the team in 1954 and expanded McDonald's into a franchise model that the humble hamburger became a symbol of consistency, efficiency, and flavor. It wasn't just a meal. It became an experience, one that millions around the world associate with childhood memories, road trips, and the comforting familiarity of the Golden Arches. So, how does McDonald's ensure that every hamburger tastes the same, whether you're grabbing a bite in Texas or New York City? It all starts with the sourcing of the raw ingredients. McDonald's prides itself on using 100% pure beef for its patties. That's right, no fillers, no preservatives, just beef. But not just any beef will do. The company works with suppliers who meet rigorous standards to ensure the highest quality. These suppliers source cattle raised on farms across the United States, adhering to strict guidelines for animal welfare and sustainability. The beef must have the right balance of fat and lean meat, which is crucial for creating that juicy, flavorful patty we all know and love. Once the cattle are raised and the beef is harvested, it's transported to state-of-the-art processing facilities. This is where the magic begins. At these facilities, the beef is inspected, trimmed, and ground to the perfect consistency. The grinding process is a marvel of modern engineering. Large cuts of beef are passed through industrial grinders that ensure a consistent texture, eliminating any guesswork. After grinding, the beef is shaped into patties using high-speed machinery that forms each patty to the exact specifications of McDonald's iconic burgers. These machines work with incredible precision, churning out thousands of patties an hour, each one identical in size and shape. But we're not done yet. The patties are then flash frozen to lock in their freshness and flavor. This step is critical because it ensures that the patties maintain their quality from the moment they leave the factory to the time they're cooked on the grill. Flash freezing involves rapidly lowering the temperature of the patties to preserve their natural juices, making sure every bite is as satisfying as the last. Once frozen, the patties are packaged and sent to distribution centers, where they're stored in temperature-controlled environments before being delivered to McDonald's restaurants around the country. Now let's talk about the other essential components of the hamburger, starting with the buns. McDonald's buns are just as important as the beef patties. They are soft, fluffy, and slightly sweet, providing the perfect complement to the savory beef. The journey of a McDonald's bun begins with high-quality wheat. This wheat is grown in fields across the U.S., harvested, and milled into flour. The flour is then sent to specialized bakeries that work exclusively for McDonald's. Here, the dough is mixed, proofed, and baked to perfection. The buns are sliced and packaged before being shipped to McDonald's locations, ensuring they arrive fresh and ready to serve. Of course, no hamburger is complete without its toppings. The lettuce, tomatoes, and onions used in McDonald's burgers are sourced from farms that follow strict quality standards. The lettuce is crisp and fresh, the tomatoes are ripe and juicy, and the onions add just the right amount of zing. These vegetables are carefully grown, harvested, and transported to processing facilities where they're washed, sliced, and packaged. The attention to detail here is astounding. Every slice of tomato and piece of lettuce is checked to make sure it meets McDonald's exacting standards. Now, let's address one of the unsung heroes of the McDonald's hamburger, the pickles. These tangy slices are made from cucumbers that are brined in a special solution to achieve their signature flavor. The pickles add a burst of acidity that perfectly balances the richness of the beef and the sweetness of the bun. Once all the ingredients are ready, they're sent to McDonald's restaurants, where the final assembly takes place. At the restaurant, the patties are cooked on flat-top grills. The grilling process is an art in itself. The patties are cooked to precise temperatures to ensure they're juicy and flavorful, and they're seasoned with a simple sprinkle of salt and pepper. While the patties are grilling, the buns are toasted to enhance their flavor and texture. This step might seem small, but it makes a big difference in the overall experience of the burger. The assembly process is where everything comes together. The toasted bun is placed at the bottom, followed by the cooked patty. Then comes a dollop of ketchup and mustard, a couple of pickles, and a slice of fresh onion. Finally, the top bun is placed, completing the burger. Each burger is wrapped or boxed with care, ensuring it stays warm and intact until it reaches the customer. What makes this entire process so remarkable is the consistency. Whether you're in Los Angeles or Chicago, your McDonald's hamburger will taste the same, thanks to the meticulous attention to detail at every step of the journey. This consistency is no accident. It's the result of decades of refinement and innovation. But McDonald's isn't just about making great food, it's also about doing it responsibly. The company is committed to sustainability, from the farms where its ingredients are grown to the factories where they're processed. McDonald's works with suppliers who use eco-friendly farming methods, such as crop rotation and water conservation. The factories that produce the patties and buns are designed to minimize waste and energy consumption, making the process as efficient as possible. So, the next time you bite into a McDonald's hamburger, take a moment to appreciate the incredible journey it took to get to you.
Have you ever wondered how your favorite ice cream makes its way from the dairy farm to your freezer? It's not just about blending milk and sugar and calling it a day. There's a whole process, a cold and creamy journey involving massive machinery, high-tech processing zones, and intricate techniques to create the perfect scoop. If you think it's all done by hand, think again. We're taking you into the heart of a mega ice cream factory where machines churn out thousands of gallons of ice cream a day. Get ready to dive into a process as cool as the dessert itself. Before we get into the nitty-gritty of ice cream production, don't forget to hit that like button, comment below, and subscribe to our channel for more amazing behind-the-scenes food processing videos. Let's rewind for a moment and look back at the origins of ice cream. Believe it or not, this frozen treat has a history as rich as its creamy texture. It's said that early forms of ice cream were enjoyed by the ancient Chinese and Persians, who mixed snow with fruit and honey. But it wasn't until much later, in the 18th century, that ice cream made its way to America, where it became a massive hit. George Washington and Thomas Jefferson were among the first American fans of ice cream, and since then, it has been a staple dessert in homes across the U.S. Fast forward to today, and ice cream is an over $13 billion industry in the U.S. alone. But how does it go from a simple idea to a product that's mass-produced in factories? Let's break it down. The journey of ice cream begins far from the factory, in the green fields of dairy farms. Milk and cream are the foundational ingredients of any ice cream, and the U.S. has no shortage of fresh dairy products, with over 9 million dairy cows producing milk across the country. In an ice cream factory, this fresh milk is delivered daily, often within hours of being collected from the farms. Once the milk and cream arrive at the factory, they're stored in large, refrigerated tanks, ensuring they remain fresh until the production process begins. But ice cream isn't just milk and cream. It's also sugar, flavorings, and inclusions like chocolate chips or nuts. Factories often work with local suppliers to source high-quality ingredients. Whether it's vanilla from Madagascar, strawberries from California, or cacao from South America, these ingredients play a key role in the flavor and texture of the final product. As the ingredients arrive, they're checked for quality, ensuring everything meets strict food industry standards. Mixing the ingredients. Once the ingredients are sourced, it's time for them to come together. In the heart of the ice cream factory, massive mixers, far more powerful than your standard kitchen appliance, combine milk, cream, sugar, and other flavorings. These mixers are built for efficiency, churning out hundreds of gallons of ice cream base in minutes. It's a process that requires precision. Too much or too little of any ingredient could throw off the entire batch. Temperature control is crucial here. The mix has to stay between 36 degrees Fahrenheit and 40 degrees Fahrenheit to keep the dairy fat stable and ensure the sugar dissolves properly. Advanced machines ensure this delicate balance, blending the ingredients until they form a smooth, consistent base. Once the base is mixed, the magic of ice cream starts to unfold. But we're just getting started. Before any ice cream base can be turned into that delicious frozen treat, it must undergo pasteurization. This process ensures that harmful bacteria are eliminated without affecting the flavor of the ingredients. In this step, the mixture is heated to around 180 degrees Fahrenheit for about 25 seconds, then rapidly cooled back down. Pasteurization is key to making sure your ice cream is safe to eat, adhering to strict FDA guidelines here in the U.S. This critical step protects consumers from any potential foodborne illnesses and keeps the ice cream fresh longer without the need for artificial preservatives. The next step in the process is homogenization. During this stage, the fat molecules in the mixture are broken down into smaller particles, ensuring the mixture has a uniform texture and flavor. If this step is skipped, the fat in the cream can separate, leading to an inconsistent product. Homogenization guarantees that every scoop of ice cream will have that smooth, rich texture we all love. In a factory, this is done using specialized machines that apply high pressure to the mix, forcing it through tiny valves that evenly distribute the fat molecules. This is a crucial moment, as it's where the creaminess of the ice cream is locked in. After the homogenization process, the mixture is sent to aging tanks where it rests for up to 24 hours. This might sound like a lazy step, but it's essential. Aging allows the flavors to meld together and the fat in the mix to crystallize, which gives the ice cream its perfect creamy consistency. The mixture is kept at a cool 40 degrees Fahrenheit during this period, and large stainless steel tanks help maintain the temperature to ensure the quality of the product. It's here where patience is key. Rushing this step could lead to a grainy texture in the final product. Once the base mix has aged, it's time to add the fun stuff. This is where the ice cream starts to take on its distinct personality, with flavorings like vanilla, chocolate, strawberry, or even more adventurous options like salted caramel or cookies and cream. Factories use giant vats of flavorings which are carefully measured and blended into the base mix. But it doesn't stop there. Inclusions, think chocolate chips, cookie dough, or nuts, are added at this stage, giving the ice cream its signature texture. Special machinery is used to evenly distribute these mix-ins so that every bite is packed with flavor. Now we're getting to the part where the mixture transforms from a creamy liquid to the ice cream we know and love. The mix is pumped into continuous freezers where it's churned and rapidly frozen. The temperature here drops to an icy -22 degrees Fahrenheit, and air is whipped into the mixture to give it that light, fluffy texture. Without this step, you'd end up with a rock-hard block of ice instead of creamy, scoopable ice cream. Factories use cutting-edge machines that can churn out thousands of gallons of ice cream in just a few hours. And the best part, you can create different textures of ice cream by controlling the amount of air mixed in. For example, premium ice creams have less air and a denser texture, while more budget-friendly versions have more air whipped in. Speaking of texture, what's your favorite type of ice cream? Do you prefer it dense and rich or light and fluffy? Let us know in the comments. And while you're at it, don't forget to subscribe for more food factory breakdowns. Once the ice cream has been churned and frozen, it's ready to be packaged. Massive automated machines fill pint-sized containers, quarts, and even industrial-sized tubs with precision. These machines work fast. Factories can fill and package over 20,000 pints of ice cream per hour. The filled containers then pass through a metal detector to ensure no foreign objects made their way into the product during the process. Once cleared, the containers are sealed, labeled, and prepped for the next step in the journey. Although the ice cream is already frozen, it still needs to go through one more critical step: hardening. This is where blast freezers come into play. The filled containers are placed in these massive freezers where the temperature is dropped even further to -40 degrees Fahrenheit. This locks in the ice cream's texture and ensures that it's fully solidified before hitting store shelves. Blast freezers work by blowing cold air across the ice cream containers at high speeds, rapidly dropping the temperature and ensuring that the ice cream doesn't develop any ice crystals, which can affect both taste and texture. Now that the ice cream is hardened and ready, it goes through rigorous quality control checks. Samples are taken from every batch to ensure that the flavor, texture, and overall quality meet the factory's high standards. Quality control teams test for things like consistency, sweetness, and the distribution of inclusions. Not only does the factory ensure the ice cream tastes great, but it also has to meet safety and regulatory standards. The FDA has strict guidelines for the production of ice cream, and these checks ensure that every pint is up to code. Once the ice cream has passed quality control, it's ready to be shipped. Trucks equipped with refrigeration units transport the ice cream to grocery stores, ice cream parlors, and restaurants all over the country. These trucks maintain the cold chain, keeping the ice cream frozen at all times to prevent it from melting or losing its texture. In recent years, many companies have also started focusing on sustainability in their shipping practices, using eco-friendly trucks and reducing carbon emissions wherever possible. And there you have it, the full journey of how ice cream is made, from fresh dairy on the farm to the final scoop in your cone. It's a complex process, but one that's worth it for that perfect creamy, sweet, and refreshing treat.